So you guys had a problem on the homework. 7.2. It was 2 problems, actually.
Without problems.
Yes. 59 and 60 on 7.2. So 59 looked like this. It was the integral of 2x plus 3 over x squared plus 3x plus 6. And then 60 was the same thing, but 1 over. Do you guys remember this problem? So the first one, 59, is pretty easy, right? What do you do for 59? This was on the section where you didn't have to like do the whole thing, but you just had to say what method to use. So what method would you use on this one? Use substitution. What would you let u equal to? X squared plus 3x plus 6, right? The reason why you do that is because the derivative of that, which is 2x plus 3, is exactly the same thing as the numerator is, right? Okay, so it works out really nice that way for that first one. But you'll notice that the bottom one, it doesn't work out that nicely at all, right? And even if you do a tiny change to the top one, that doesn't work out. So like, you know, for example, I just happen to change this into a 2, let's say. The same method no longer works, right? I have more significant problems on my hands. You guys agree? Okay, so, but 59 as it was simple. Now, 60, what did you guys say to use? Yeah.
There was an option that you hadn't learned it yet, and that one.
Well, yeah, I would say that's a pretty good option. I mean, you can, so technically you could hypothetically do it with the amount of knowledge that you knew so far, but it required remembering something from way back in algebra called completing the square. Do you guys remember that?
Right.
Right. Completing the square. That, of course, you remember how to complete the square. So the idea was before we do that, you guys remember this, right? 1 over a squared plus u squared du is 1 over a inverse tangent of u over a, right? This one we've now derived twice using 2 different methods. Yes? You guys agree? Okay, twice using 2 different methods. Once substitution, twice yesterday. Trig sub. Okay. All right, so this is how completing the square works. In case you don't remember. What you do is you go, okay, you have x squared plus 3x, and then you leave a space, and then you'll put plus 6. Okay, then what you do is you grab the middle term, the 3x, you grab that number, so it's 3. You divide it by 2, which gives you 3/2, right? And then you square that number, which is 9/4. That number, special number, 9/4, you add it and subtract it.
Can you write that down, perhaps?
No, I don't want to write it down. Okay, so, but it's on video. It's on tape. You can go back and you listen. Okay, so we grab that number, divide it by 2, and then we square it. I actually, for my algebra class once, I made a video on completing the square. So maybe I'll give you guys that link. It's on YouTube. Or you can just YouTube other videos on completing the square. It's not hard for you guys. You guys can do it. It's no problem. Okay, so we add 9/4 and then we subtract 9/4. And then what happens is that this trinomial, this is a perfect square. And this can be factored into x plus, the plus is whatever the sign in the middle is. And then this is just the square root of that number, the last one. So do you guys agree that if I square x plus 3/2, I would get that trinomial up there, right? So that's why it's called completing the square. You've just completed a perfect square. Okay. All right. So, and then plus, what's 6 minus 9/4? Last time I checked, that was 15/4. Interesting. Okay. So what this is equal to is this is equal to the integral of 1 over, so instead of x squared plus 3x plus 6, you have x plus 3 halves squared plus 15 over 4. And can you guys see where to go with this from here? What would we do at this point? Any ideas? Before we use tangent, probably a good idea to use substitution. What would we let u be?
X plus 3 halves.
You let u be x plus 3 halves. And then du would just equal to dx, right? Do you have a question, Whitney?
Yeah.
Yes.
It's kind of on back to completing the square. Can you explain to me why it's okay to do that? Just how you're not allowed to like when you just have an expression, if you just times a number by that, it's changing the whole expression.
Yeah, that's why we added the number and then we subtracted it immediately after.
Okay.
So it's like you're adding there.
Okay.
So that's why it's okay. Okay, so this is equal to 1 over u squared plus 15 over 4 du, right? You guys agree? And then this is just using our formula that we derived a couple times now. This is equal to here, what is a? If this is, if a, so here if I think about putting it in that form, right? I would need to have, square root of 15 over 2 squared, right? And then a would be square root of 15 over 2, yes? Okay, so then this would equal to 2 over square root of 15. Why is it 2 over square root of 15 and not square root of 15 over 2? Yeah, it's 1 over a, right? So it's 1 over a, which is that inside of the parentheses. So it's 2 over root 15 inverse tangent of Okay, let me do u over a, which is just 2 over square root of 15, right? And then this looks a little messy, but oh well. U is x plus 3 halves, right? So this is 2 over square root of 15 inverse tangent of 2x plus 3 halves over square root of 15. Okay. So the important part that I wanted to bring up was the whole completing the square part. How you can turn a quadratic expression into a form where you can turn it into something that you could use one of the antiderivatives that we already know, or something that's similar to it that you can use trigonometric substitution with. So that's what we're doing today. Good times? Okay. All right, so any questions with anything we did there? We're good with completing the square, all that stuff? No? Jessica, do you have any questions?
No.
You sure? Okay. All right, so I've got a good one for you guys. Let's see. So let's do an example. Well, actually, why don't we... All right, so before I give you guys an example, let's write down our three forms. When to use trig sub. Okay, so what was the first? Give me one form. One. Okay, x squared plus a squared. If that's my form, then what's my substitution? What is it? I let x equal to a tangent theta. Okay, sorry. Okay, what's another form?
A squared minus x squared.
Okay, I wrote the other one. but I'll put that one down. A squared minus x squared, and x squared minus a squared, right? So if I have x squared minus a squared, what substitution do I use? X equals to a secant theta. And if I have a squared minus x squared, I use x equals to a sine theta. Okay, so those are my substitutions. And do you guys remember why we do those and not some other ones? Because when we substitute, what happens? We are able to use a identity to turn multiple terms into one single trig function, and then that allows us to find it, right? Okay. All right. So, I lost my example here. Don't worry, I have it on hand. I have big plans for you guys today. Great plans. Okay. All right. Example. The integral of the square root of 5 plus 4x minus x squared. Okay, now at first glance, does this look like a trigonometric substitution?
Is that squared under the thing?
Yes, it is. Everything is under the root. Does it look like a problem you would use trigonometric substitution for? No, right? Because trigonometric substitution, what tells you to use it is you have, x squared minus a number, or a number minus x squared, or a number plus x squared, right? Okay, and this doesn't look like that, but then you remember, from algebra, or class today, you can turn that into, complete the square, right? Okay, so then you go, this is great, of course. Let's complete the square. Complete the square. Okay, so we'll complete the square. Now this one is a little bit different because, just a little bit, because I have 5 plus 4x minus x squared. So it might be a good idea to put it in order, right? So like the x squared term first and all that stuff. So if I should write it like this, right? Minus x squared plus 4x plus 5. And then you probably don't remember, but to complete the square, before you do all the nice things that you do, the x squared term can't have a number in front. So I have to do the number 1, and that one's a negative 1, so we have to factor it out. So I'm going to factor out the negative. Then I'll have x squared, what's the 4x going to be? Minus. I'm going to close the parentheses, and then the 5, I'm going to write it outside because that's not part of my completing the square business that I'm going to do, right? Okay, you guys ready to complete the square?
Yes.
Yes, good. All right, so what number do I grab and divide by 2 and square?
4 divided by 2 squared.
Okay, so 4, right? Or negative 4, it doesn't matter. Divide by 2, you get? 2. Square? 4. And then I'm going to add and subtract, right?
Yes.
Okay, so I grab 4, add, subtract. Bam, I just made a mistake. What is it?
You're really subtracting another 4, so you need to add it.
Aha, excellent detective work. Right here, notice, I added 4. Looks like I added 4. But no, I didn't really add 4. I really am subtracting 4 because that's being multiplied by a negative. So this 4 is really being subtracted, so this one I have to add. Yes. All right, so you get, just little things to be careful with. Okay, so, I don't know why it did that. It just jumped. Okay. All right, so then we continue. So we factor. Oh.
If you factor it out, shouldn't it be negative 5?
What? No, I didn't factor out the negative 5. The 5 is just plus 5. It's just there.
Oh.
But I didn't factor the 5. The 5 wasn't in the factor. Negative is outside of the 5 business. Okay, so I have x, plus or minus? Minus 2 squared plus 9. Okay. All right, so this is what 5 plus 4x minus x squared is. And probably what we should do is rewrite it and put it in this, just the other way around, 9 minus x minus 2 squared, like that. Yep.
Why did you do it?
Oh, I just wanted it to be in the form that I wanted. I mean, there's nothing wrong with having it this way, but this is like, you want the negative sign in between, right? So it's just to make it look more like the form that we want. Okay, so this is what we have so far. And then, so this is what's going to be inside of the root, right? So then what do I do now? Yes, Joe?
Turn 9 into 3 squared.
Do what?
Turn the 9 into 3 squared so you can have that identity.
I can do that, yes, but there's something else that I need to do. I mean, you can do that to make it look more like the form that you want, right? But, so like turn this into 3 squared like that. So why don't we, okay, let me do this. So let me do, okay, let me do, well, I want to write it down again, but I want to make sure I'm going to have enough room. So I'm going to rewrite it here. The square root of 5 plus 4x minus x squared dx. This is equal to the integral of the square root of 3 squared minus x minus 2 squared dx. So all I did was just, I just rewrote the integral, and then this is what we just found by completing the square, right? Okay. All right, now, what are we going to do now? Trig substitution, yes. Let's see. Do you guys want to go the... Okay. All right. No. I hesitate to move too quickly. So before I continue, what should I do with this x minus 2? Yeah, a little u substitution, right? So if I let u equal to x minus 2, then du is equal to dx, right? Do you guys agree? So then this would equal to the integral of the square root of 3 squared minus u squared du, right? Okay. All right. Now I'm ready to do my trig substitution. So what would I do? U equals to 3. Okay, let's go back and take a look. So those are my 3 forms, right? Notice that I have my number minus u squared, x squared. It doesn't really matter. And that one is, I'm going to use sine, right? Okay, so I'm going to let u equal to 3 sine theta, right? Why don't I let u equal to 9 sine theta? Yeah, it's a sine theta, right? And a squared is equal to 9. So it's the square root of that number. Okay, so then what is du equal to? 3 cosine theta d theta. Okay. And then remember we did this last time. You should also do the square root part. So the square root of 3 squared minus u squared is equal to the square root of 3 squared minus, if I square u, what would I get? 3 squared sine squared theta, right? You can write it as 9 as well, but okay, so then this is equal to 3 squared times, if I factor out a 3 squared, I would get 1 minus sine squared, right? You guys agree? Okay. So what can I do with the square root of 3 squared? That's just 3. And this is where I use my trig identities, right? So I have 3, and then what is 1 minus sine squared? 1 minus sine squared is cosine squared, right? And the square root of cosine squared is just cosine. So this is actually 3 cosine theta. You guys agree? Okay, so that's the whole point. So if you get to this point and you don't end up with a trig identity there, then it means you either made a mistake along the way or you chose the wrong substitution from the beginning. Like for example, if you would have picked let u equal to tangent, then you would have ended up over here with 1 minus tangent squared, and you can't do anything with that. You can't change it to anything, so then you would be at a loss. So this one, sine, works in this case because you can turn it into cosine squared. Thumbs up so far? Okay. Is the speed okay, or am I going too slow, too fast? You guys good? Okay. All right. So then this is equal to the integral. So, okay, so let's go in and substitute. So this square root, all this stuff, that is this one right here, right? That's 3 cosine theta. You guys agree? Okay. And then du is another 3 cosine theta. So du is 3 cosine theta d theta. Okay, so then this is the integral of, yeah, we can take it out or just leave it in. All right, we'll take it out. 9 cosine squared theta d theta. And then how do I find that integral? The reduction identity, right? So, okay, so let's keep going here. So this is equal to 9 times the integral of, what's the identity? Cosine squared is equal to 1/2 times 1 plus cosine of 2 theta. Okay. And then, remember that's a really important one. So this is equal to 9/2. I just took the 1/2 out. And then let's find the antiderivative. What's the antiderivative of the number 1? Theta, right? So that's just theta. And then theta plus the antiderivative of cosine of 2 theta, which is sine of 2 theta over 2. Cliff is on fire. Ooh, wait. Sorry. Ooh. Sine of 2 theta over 2. Okay. Now, plus C. Okay. Am I done?
No, because we're back to the original.
Yeah, we have to go back to the original variable. Yes.
Can you explain the second step down? Or
This one?
Yes.
This?
How'd you get there?
To get to sine of 2 theta?
Yes. Up one. Yes, there.
Here. Oh, that's the identity, the reduction identity. We have one for cosine squared and one for sine squared.
And then the next one's just the.
Yeah, antiderivative. Yeah.
What's the reason that when you're at 9 integral cosine squared theta d theta, like third one up, why couldn't you just use sub again and then solve
Use
it?
what?
Use sub, like for cosine squared.
Because you can't do use sub because you would need to have a sine function in there
Okay.
to be able to use it. You could, if you remembered, use the reduction formula, but how many of you guys have the cosine reduction formula memorized? Yeah. And then, well, if you memorize the cosine one, you'd have to memorize the sine one as well. Then you have to memorize tangent and secant, no, not very fun. So this is much easier because you need to know that one anyways, the reduction identity. But you have a small problem. Well, we have to go back to the original variable, right? Do you guys see the problem that we're going to have in the future? Or not yet? We'll continue and I'll let you guys see the problem in a minute. Okay, so what we need to do now then is we need to go back. So let's remember, what's the substitution that we did? We let u equal to 3 sine theta, right? Wasn't that what we did? So this means that u over 3 is equal to sine of theta, right? Oh, yes, Teresa? Do you see our problem now? Oh, not yet? Oh, okay. All right. Does anybody see our problem? So we need to find, theta is easy to find, right? What is theta?
You're gonna have a sine times an inverse sine.
Theta is inverse sine of u over 3, right? Based off of this previous line. So if u over 3 is sine theta, then theta is inverse sine of u over 3. No problems there. What is my problem? The next one is a problem. Sine of 2 theta. So I know sine of theta is u over 3. Is sine of 2 theta to u over 3?
No.
Absolutely not, right? Absolutely not. Okay, so what do I need to do?
Identity.
Yes, exactly. Excellent work. Okay, so we use an identity that is not too difficult to remember.
That's right.
Okay, so this is equal to 9 halves. I'll just keep it as theta for now. Okay, sine of 2 theta is equal to 2 sine theta cosine theta. And then, so 2 sine theta cosine theta, then that's going to, the 2 is going to cancel out with that 2 right there, right? Yes?
Yes.
Okay, so we're almost done. Because all we need to do is, so we know theta, we know sine, all we're missing is cosine. How do we find cosine? You guys remember from yesterday? Yeah, do a right triangle. Like we did yesterday. What color would you guys like your triangle? Green. A nice earthy green. Okay, so we've got theta here. We've got, so what sides can I label based off of the angle that I've chosen? Since sine of theta is u over 3, that means opposite is u. Hypotenuse is 3. So then adjacent would be, by the Pythagorean theorem, square root of 9 minus u squared. Can you guys see that blue color?
Not really.
Yeah. Okay. I'll never use it again. Sorry. I inconvenienced you with my choice of color. Okay, so off we go. This is equal to 9 halves times theta, which is inverse sine of u over 3. I'm going to leave a space there for u because I don't want to put u. I want to put what u is equal to. Okay. Plus sine, which is u over 3, right? Okay, so again, I'm just leaving a little space there. If you remember what u is, you can put it in right now, but I don't remember at this point in time. What about cosine theta? Cosine theta is the square root of 9 minus u squared, right, over 3. Okay, and what was u? X minus 2 or x plus 2? X minus 2? Okay. So u was x minus 2. And that's it. That's all you have to do. Plus c.
How did you get the triangle there with the inverse sine? Isn't that the sine?
Well, no, we got the triangle from sine. Sine of theta is equal to u over 3. So, if this is theta,
Okay. All right, I got you.
yep, opposite over hypotenuse. Yes.
Could you skip the substitution and then just have X.
Yes, that's what I was hesitant about doing. So let's talk about that just to see if you guys would be comfortable with that. Okay, so the question is, instead of, let me see. Okay, right here. All right, so right here. Instead of doing a U substitution and then a trig substitution, what you can do instead is do directly choose, let me see. What color? Okay. Instead of doing this substitution, you can do, here for example, let x minus 2 equal to 3 sine theta. And then dx would equal to 3 cosine theta. And so the only thing that would really change, so see how right here everything is in terms of thetas, 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 thetas. When you go back here at the very end, instead of having these u's, you would have x minus 2's, x minus 2, x minus 2, x minus 2, x minus 2. And so when you do everything out, you would not go to u and then x minus 2. You would just go directly to x minus 2. It's up to you. It's not that much time saving, but sometimes it does. Thumbs up? Another? Semi? Okay. All right. So I've got another one that's even more fun than that one. That was actually, believe it or not, that was a short one. Actually, in my other class, we did the other one first. But then I was like, I think we should have started with this one. See, that's what happens. I mess up in my first class, and then you guys get the refined version of class. Don't tell them I said that. I'm going to have to edit that part out. I'm going to have to go in and edit that part out later so that they don't know. It's a secret. Okay. All right. You guys ready? We probably won't have time to finish it. But. All right. So what do we do? Can we do substitution? We should always check. Can we? No, we cannot. If this x right here, if this x wasn't here, then we would be able to use substitution, right? But it is there, unfortunately. So we can't do substitution because if we let u be the denominator, the inside of the root, we would get the derivative is 2x plus 1, and we don't have the plus. Well, we don't have the 2x plus 1 on top of that. Okay. All right, so then what do we do? We notice the bottom is a quadratic, and it is not a trig sub form, but we know we can do complete the square. Yeah. Okay. Our favorite thing to do now. All right, so we complete the square. Complete the square. All right, so now you guys are experts at completing the square. All right, what's the number that I'm going to add and subtract? 1/4, right? Because I grab 1, I divide it by 2, 1/2. 1/2 squared is 1/4. So I add a fourth, subtract a fourth, and then this factors into x plus what? 1/2 squared, okay, plus 3/4. Okay, now, do you guys feel like doing the u substitution thingy or direct? What do you guys feel? I know Teresa wants to do direct, but she's not the only one in the class.
Yeah,
What do you guys think?
sure.
Direct. Let's go direct. Okay. See, I like that attitude, Joe. Just go for it.
Yeah,
Yeah. Okay. We're just gonna go for it. So
I'm excited.
you're excited. Okay. Me too.
I see my homework hours.
Okay, so then we have, all right, so we complete the square. We get x plus 1/2 squared plus 3/4. Oh, you think these are long? Wait till you get to partial fractions. Whew. Whew. Okay. Anyways, so let's put this. Maybe we'll put it in a little box like this, so we contain it.
Partial
Contain the
fraction.
damage.
Fraction of a fraction.
No, you don't want to worry about that.
Isn't that still a fraction?
Okay, so then we do. Now we notice that it's a trigonometric substitution, right? So then, what form is it? Squared plus a squared, right? So we would do a tangent. So what we do is we go, okay, so we're going to do our trig sub. Our trig sub is now going to be x, instead of x, it's going to be x plus 1/2 equals to a tangent theta. What is a? A is the square root of this number, which is root 3 over 2. Yes? Okay. So, then, interesting situation here. This may be not the best problem to choose this method, but oh well. Okay, so then what is dx equal to? Dx is equal to root 3 over 2 times secant squared. Notice that when we get the derivative of the left side, the derivative of 1/2 is just 0. So that's why we just get dx. Right? Okay, and then what else do we have? What else do we need? The root part, right? So the root,
Why do you need that again?
well, it's recommended that you do it ahead of time so that you don't have to work out all the simplification steps on the fly as you go. So it's better you do it once at the beginning, everything, and then you just plug everything in. It's easier that way. Keeps things organized. So you have
So that
x.
red equals the equation under the square root right now, right?
The red. What red?
That equals the area. That equals under the square root of the integral, right? Those are interchangeable.
I'm not sure what you mean.
The pink?
What?
You see the pink?
This pink?
Uh-huh. That equals the x plus 1/2 squared plus 3/4, right?
Oh, yes. We're gonna substitute that into here.
Okay.
Yeah, definitely. So this is equal to the square root of, instead of x plus 1/2, I'm going to put this right here. Right? This one? So that's going to equal to, so if I square this, I'm going to get 3/4 tangent squared theta plus 3/4, right? And then if you do the same thing, you factor out the 3/4, and then you take it out of the radical, you would get square root of 3 over 2, right? Square root of 3 over 2. And then inside you would have the square root of tangent squared plus 1. Tangent squared plus 1 is equal to secant squared. Square root of secant squared is secant. Yes? Okay. So root 3 over 2, secant theta. And all of that, we put it into the integral. So here, let's put this in its own little box. Oh, nice organizing boxes here. Okay, so then this is equal to the integral of, let's see. So all of this root on the bottom is, what is it? All the stuff on the top. What stuff on the top?
Do x, would that be a and then dx?
We'll deal with that problem when we get there. Okay, so let's plug in what we know. We have the root part, right? All of this root right here is root 3 over 2 secant theta. So if I put secant theta, and if I have root 3 on the 2 on the denominator, is it okay if I do 2 over square root of 3 like that? Yeah? Reciprocal? Okay. Then then dx is equal to root 3 over 2 secant squared theta d theta. So this is square root of 3 over 2 secant squared theta d theta. Yes? Okay. Now I'm missing this x here. What do I do with that x? Maybe I should have left a little room there for the x. Let's go back here. Oh, this is for the x. Secant squared theta d theta. Okay. And then what is x equal to? What is it?
You have square root of 3 halves.
Square root of 3 halves tangent minus 1/2. Okay, so square root of 3 halves tangent minus 1/2. Now this is a time when doing u instead would have been better, but oh well. Now we've created this problem, we've got to deal with it. Okay, so now let's simplify. So notice that the 2's go away, and then those root 3's go away. What else simplifies? One of the secants on top and the secant on the bottom, right? So adios, 1 and 1. So notice what we have is that's not too bad, right? Because, so what this equals to is this is equal to the integral of, I'll write it down in 2 steps so that we don't get lost here. This is root 3 over 2 tangent. So right now I'm writing what's inside of the parentheses, minus 1/2. This is in the parentheses. And then it's that times secant theta d theta. Okay, so let's, any ideas? What should we do? Suggestions? Yes, distribute. Distribute. Excellent suggestion. Distribute the secant. So we have root 3 over 2 secant theta tan theta. Oh, maybe we will finish. Maybe. Minus 1/2 secant theta d theta. Okay, good times. All right, so antiderivatives. Antiderivative of secant theta tangent theta. Secant theta. Good. So that's secant theta. And then the antiderivative of secant theta, we did that yesterday. That is natural log of absolute value. Secant theta plus tangent theta plus c. So far, so good? Okay, we're almost done. Check it out. Oh, we're going to finish. We are going to finish. Okay, all we need to know now is our substitution. What was it? X plus 1/2 equals root 3 over 2 tangent theta. Okay. Okay, that's all we need to know. So over here on the side, x plus 1/2 equals to root 3 over 2 tangent theta. So this means that tangent theta is equal to x plus 1/2 times 2 over square root of 3. Okay. And that is enough to make a right triangle, because all we really needed to do is find secant, right? So let's do a right triangle. We always do these little right triangles, but in reality you don't have to do a right triangle. Do you guys know what another option would be? What would be option 2? You know tangent, you want to find secant, you can? Okay. Think about it, and you can tell me later. All right, so if tangent is 2x plus 1/2 over root 3, the suspense. I'll tell you in a minute. All right, so what would the opposite side be? Oh, okay. Well, it is, right? If you distribute the 2. 2x plus 1, and then adjacent would be square root of 3. So then the hypotenuse by the Pythagorean theorem would equal to the square root of 2x plus 1 squared plus square root of 3 squared, which is just 3. Okay, so then this is equal to, so, okay, I'm ready. Should I write out explicitly what secant theta is? Okay. So based off of this right triangle that I just drew, secant theta would equal to, okay, square root of 2x plus 1 squared plus 3, right? Hypotenuse over adjacent, which is square root of 3. Okay, off I go. So then we just plug everything in. So secant theta is square root of 2x plus 1 squared plus 3 over square root of 3 minus 1/2 natural log absolute value of secant, which is again the same exact thing, right? What we just wrote down one moment ago. So square root of 2x plus 1 squared plus 3 all over root 3. Okay. Plus tangent theta, which is two x plus 1 over square root of 3. Close absolute value plus c, and that is it.